Hello everybody. Now coming to the next chapter, basics of automotive ECUs and CAN architecture used in vehicle diagnostics and onboard diagnostics. So to proceed further, understanding automotive ECUs and control area network architecture is critical to grasp how vehicle diagnostics and onboard diagnostics work. So these are like the actual nerves which carry the information in a human body. Okay, these are analogous to the nerves which carry the information in the human body. So this communication is as important as nerves. So these systems form digital nervous system of modern vehicles, enabling communication, fault detection, and control of various vehicle functions. Now, what is an automotive ECU, electronic control unit? Well, this is something which I think everybody knows, but let me briefly touch upon it. Now, a ECU is a microcontroller-based embedded system that monitors and controls various electronic systems and subsystems in a vehicle. All right. Now, coming to the function in diagnostics, the ECUs collect data from sensors and sends commands to actuators. Now, they continuously monitor component behavior and store diagnostic trouble codes when faults are detected. They are the key nodes in OBD systems. They are the key nodes in the OBD system. Understand this very carefully. All right. Now, what are the various types of ECUs in the vehicle? Now, this is more like general knowledge, but I'll briefly touch upon it. ECU type like engine control unit, transmission control unit, body control unit, ABS control module, airbag, SRS module, infotainment ECU, ADAS ECU, battery management system. These are the various types of ECUs, and I will not go into explaining it because I am sure all of you with decent automobile knowledge have some prior knowledge about the types of this ECU. But anyway, in case you have any doubt, you can always pause the video and read the functions which I have mentioned here. Now coming to the architecture of ECU communication, the role of CAN bus. What is CAN bus? Control Area Network is a robust fault-tolerant serial communication protocol used in automobiles to allow multiple ECUs to communicate with each other without central host computer. I'll read this sentence once again because it is imperative that you understand what is this CAN bus and why it is so important to why this CAN bus has become such a robust communication protocol. It is a robust fault tolerant serial communication protocol used in automobiles to allow multiple ECUs. It allows multiple ECUs to communicate with each other without a central host computer. So with one fell swoop, CAN has eliminated the necessity of the central host computer, which makes CAN such a user-friendly communication protocol. And it is absolutely essential for real-time communication and diagnostics. Now, when it comes to key features of CAN, multi-master message-based protocol. Now, one of the important features is the speed 125 kbps to 1 mbps, depending upon whether it's the standard CAN or CAN FD. Now, when it comes to robustness, it is very high resistance to electrical noise, and its efficiency only transmits messages when data is needed. Now, coming to the basic CAN architecture diagram, this is a basic CAN architecture diagram. I request all of you to go through it. Like for example, these are the various types of the ECUs, and as I said, there is no central host computer, but still they are able to communicate with one another. Now each ECU is a node on CAN network and can send receive messages. All right. Now, in case somebody is interested in CAN protocol, there is a beautiful course in Udemy by author called Sham, but I will write his name here. Sham, yes, H Y A M. This is his first name, and his surname is Bhatt, B H A T. I request all of you to read this particular, go through this particular course in case you want to know in and out of the CAN protocol. I personally have not seen a better training than the training given by this gentleman. All right. So how can ECUs, how can and ECU support diagnostics? Now we are coming to the actual core of the lesson. Now diagnostic communication pathway. In the diagnostic communication pathway, sensors send data and ECU analyzes it. All right, and this sending the path data through the communication pathway. That's where CAN comes into picture. And ECU detects fault, sets the DTC. For example, P0301 misfire in cylinder 1. ECU sends DTC over in the chip over CAN bus to gateway ECU, and gateway ECU forwards it to OBD port under dashboard. Now scan tool connected to OBD port reads to fault using standard protocols like ISO 15765. All right. So CAN based OBD2 is based on governed by the standard ISO 15765. Now coming to the common OBD communication protocols over CAN. Now these are extremely important. ISO 15765, ISO 14229 UDS, ISO 11898, SAE J1939. This is exclusively for heavy duty trucks, and also this ISO 914, which is still used in older vehicles. Of course, this is rapidly becoming obsolete, but still some old vehicles they are using this protocol, keyword protocol 2000. The CAN message format, coming to the field and description, identifier, priority, and message type. And DLC data length code, length of data, which is 0 to 8 bytes in classic CAN, up to 64 in CAN FD. Now, when it comes to the data, the actual message, and coming to CRC, error checking field, ACK, acknowledgement for receiving ECU. So these are the various types of various formats that are included into the CAN message. Now use case, diagnostics over CAN. For example, we will talk about this use case. Reading a oxygen sensor fault. Now oxygen sensor detects abnormal oxygen levels, and engine ECU identifies the issue, generates the DTC P0130, and ECU broadcasts the fault over CAN bus. Now, when it comes to the fault, the gateway ECU relays it to the OBD2 port, and technician plugs in a scan tool and reads the code. Now, talking about using the UDS, technician can also clear the DTCs, monitor live data, and run component tests. Example, activate EGR valve. Okay, so these are the this is one important use case talking about discussing the diagnostics over CAN. Now, what are the various advanced CAN concepts? First is when it comes to ECU, it stores faults, runs control logic, interacts with sensors and actuators. And when it comes to CAN bus, allows ECUs to exchange diagnostic and control information. And when it comes to OBD port, interface for technicians to access diagnostic data. And when it comes to protocol ISO 15765 and UDS, now this is exactly how the diagnostic messages are formatted and exchanged. Now, so I hope all of you got a decent idea about the CAN usage of CAN in diagnostic protocol. Now, when it comes to summary, we will see in this table on the left side, we are seeing the term and we are seeing the explanation on the right side. So when it comes to CAN FD, the faster, longer messages up to 64 bytes, better for ADAS EV. And when it comes to gateway ECU, the filters, routes, massages between zonal architecture groups ECUs into zones for simplified wiring and diagnostics, and bus load measure of how busy the CAN network is. All right, it affects the diagnostics responsiveness. All right, so I hope all of you got a clear cut idea about the CAN concepts in onboard diagnostics. Thank you.